Okay, it's 1 o'clock. 1 o'clock Central Time. It's Tuesday. Welcome to our next HDF clinic after we had a little bit of a hiatus. We are back in business and plenty of things to talk about. There weren't any questions on our Google Sheet or on our Google Doc. I'm going to pause anyway and ask for those who are here today. Are there any questions about HDF5, about applications, things that you heard, read? Speak up, otherwise, yeah, we'll pause here and there to ask that question again. Anybody? No? Okay, then I'll just go ahead, and I prepared, as always, a few notes. Last week's highlights announcements, as many of you probably know, we had our great Hug 21 event last week, Tuesday, Wednesday, and Thursday. Great turnout, great program, and videos are starting to show up on YouTube. I linked here the link to that playlist on our YouTube channel. So in case you missed it, you can catch up and start binge watching the HDF5 channel. And yeah, there were some great talks, and I'll go back myself definitely and watch a few of these again. Then there's been plenty of activity on the forum, but maybe, yeah, before I go there, I'll ask again, does anybody have a question so far? No? Okay, then I'll just continue. On the forum, a few posts sort of stuck out. They are all linked in here. The first one was by someone who was trying to create a user-defined compound type with the additional element that one of the fields of that compound type was intended to be either an array type or some kind of a sequence type. And the big difference here is, so if you want to model that as an HDF5 data type, you have to sort of look at the sort of C or C++, whichever language you are coming from, your in-memory data structures. You have to look at their layout, and the breakpoint here is whether that structure, the fields of that structure, are contiguously laid out in memory, or whether they are not contiguously laid out in memory. And I just brought two examples here that were mentioned in that post. So that user had a struct called instruction. It was basically a timestamp field, and then in one case, a fixed size array of keys. And in that case, this is perfectly contiguously laid out. Okay, I haven't shown what the type definition of key is, but let's assume that that is something contiguous. And max keys is some constant, and then you can go ahead and define a compound, an HDF5 compound data type with two fields, and that second field is going to be of class H5T_array, as we call it in HDF5. On the other hand, if you do not know or you cannot bound in any reasonable way the number of keys associated with such an instruction, then you're pretty much stuck. You have all you have is really a pointer to a sequence of keys, of which there can be arbitrarily few or many. And in that case, your only option is pretty much to go with a variable length sequence type. So that would be H5T_VLAN class, as we call it. And that's pretty much it. And yeah, there was a little bit discussion around of course, you prefer to reuse or use most of the structures that you have in memory without doing a lot of copying and so forth. But pretty much this is what it comes down to. Okay, I'm going to stop and ask, are there any questions, comments, thoughts? Otherwise, I'll just continue. I have a small screen here. I'm a little handicapped here today. I'm not at my usual workstation, but I'll get through this. Another interesting post by Werner, and some of these discussions sort of came up on the sidelines of HUG. So Werner suggested that wouldn't it be nice to, instead of reading a data set or a subset of elements of a data set in a user-provided buffer, wouldn't it be nice if we could somehow memory map the elements of that data set into a region in memory? I mean, Unix type operating systems, but also Windows nowadays have done that for the longest time. They have this concept of memory mapped files, and where you can basically ask the operating system to basically use its swapping, its paging mechanism to map a region of the file into the address space of a user process, and then as the user application references addresses in that region, if the underlying region of the file is not yet present in memory, then the operating system will do that in the background using its swapping, its paging mechanism. And that's actually a trick that a lot of people have used over time in sort of in the Python community and other communities. And maybe now is the time, or there is room here to really codify that in a new read function, for example. And Werner's suggestion was to say H5D read mapped, and then ... here stands for pretty much the arguments, the same arguments that you have in an ordinary H5D read call, where you have a data set handle, you have an in-memory data type handle, you have a data space handle potentially with a selection on it, a data set transfer property list, and so forth. But then again, not reading data set elements into a user buffer, but really this is a star here, creating a pointer, returning a pointer to the user that points to this shared memory mapped region. And of course, with the understanding that if that memory region is writable, that any change of that memory region would eventually result or be equivalent to an H5D write, because you would be modifying elements of a data set in memory, and then perhaps you would want the changes to be eventually committed to the data set contents in the file. So very interesting suggestion from Werner there. I'm going to pause, ask, are there any questions so far? Any? If that's not clear, please ask, and I'll try to explain it again or a little differently, but yeah, very interesting. Okay, the next one is also from Werner. He raised an interesting issue that becomes, I think, increasingly interesting and important, which is that most of you are probably familiar with this concept of an external link. So an external link is basically in HDF5 groups, we have, sometimes we say, well, a data set is a member of a group, or another group is in another group. That is in a way very sloppy, a very sloppy way of speaking and saying, well, a group, another group can be linked that's how this is actually implemented, can be linked to a given group, or a data set that's in a group is really linked to that group, because again, this is implemented through links. There is nothing, if you think it's not like a box and there's another box nested in there. It's really a link, not nested boxes. Anyway, with external links, you have the ability to refer to other HDF5 objects, not just in the same file, but also groups and data sets and named data types in other HDF5 files. Now, the interesting issue that he raised is, well, there was also a talk at HUG 2021. There will be a way to load virtual file drivers dynamically. And so what if you have an external link, which you can think of logically as sort of a pair, where the first component of that pair is a file name or a way to look up which HDF5 file we are talking about. And then the second element, a path name inside of that HDF5 file to locate that, that object, that external object, so to speak. Now, the problem is, of course, that as we know, the HDF5 library supports different virtual file drivers, and from the file name itself, you can usually not tell which virtual file driver you should use to open that HDF5 file, and you can try that. You can try different virtual file drivers and then hopefully hit upon the one that does the magic. And this is a rather manual process. So right now, for example, if you have such an external link and you know that, okay, in order to traverse or resolve that link, I need to use a different virtual file driver. There is an API call called H5P set elink fapl. So you would provide a file access property list with which virtual file drivers are set on file access property lists. So that's why it's a fapl. So you would create a file access property list with the BFD that you would need to open that file being referenced by the external link. But then again, you either have to have that knowledge a priori, or you would, through trial and error, you would have to discover that dynamically. And all of that is not very convenient and potentially error prone and so forth. So Werner's suggestion is to come up with a better solution. I mean, there are a few things that come to mind. For example, well, if you think about the World Wide Web, when you look at the structure of a URL, then the first thing is usually, I think it's called the authority, the HTTP or the HTTPS or the S3 or the, there are all kinds of authorities, I think that's what this is called, that in a way then indicates the protocol or the mechanism with which you would resolve that URL. And something like that might work here. But then nevertheless, it's an important issue for which we have to come up with some creative solutions. And yeah, it's interesting that Werner raised it. Okay, any questions? So that was another, again, HUG usually answers a lot of questions, but it also raises a lot of new questions, and it's always good to see people being engaged and having good ideas and making great suggestions. Okay, here's another one. Somebody asked about chunk cache performance. Somebody was observing, I believe, in Python, not achieving the desired performance in their script or in their program, and they were playing with modifying the parameters that we offer, that the HDF5 library offers, and that are exposed through the H5Pi API, that they still couldn't make it work. Well, we don't know exactly what's going on, but somebody posted today a GitHub issue because the user was seeing that when they made that raw chunk cache 4 gigabytes large on a 12 gigabyte RAM equipped machine, they were sort of getting crashes, and not of the machine, but sort of the Python shell, the Python environment just failed. And so there might be more going on here than just an issue related to chunk caching. But I just dug up, there is a nice RFC by Quincy and Neil Fortner. They wrote this, I believe, 2008, that sort of discusses the different APIs and the function of the role of these parameters and so forth, and strategies and so forth. And then there's an example. So it's a great, I think it's a great document, and it's available on our docs portal. And so this is at docs.hdfgroup.org, HDF5/RFCs. And there are many other RFCs, so I didn't count, but there are many dozens of RFCs starting in, I think in the late 90s even. So for certain topics, if you're lucky, there might be an RFC that covers just question that you are interested in. And the fact that some of them are older doesn't really matter that much depending on the topic, because, for example, as far as the raw chunk cache goes, I believe that not too much has changed. I mean, which is good news in the sense that what was implemented back then seemed to have worked and be effective, and there was no need to change it. And of course, that might be different for other topics, but for the raw data chunk cache, I believe that's true. Okay, any other, are there other questions about this or any other topics? No? Okay, then I'll just press on. There was an interesting question that someone asked, I believe a week ago. They were using the Fletcher 32 filter, which is basically creating checksums of chunks, Fletcher 32. So it's not, strictly speaking, it's not a compression filter like gzip or something like that. It's really just something that calculates the checksum, and it's actually good to have if data integrity is important to you. It will not be able to prevent corruption for you, but it will definitely, if something has happened to your file and an element or bit or byte on a chunk has changed, that typically changes the checksum for the entire chunk, and then on reading you would detect, or the HDF5 library would detect that some kind of change or corruption must have occurred. So the user was asking that he was planning to apply this Fletcher 32 filter to a data set of variable length strings, and he was surprised to see that when he created that data set and then tried to apply that filter, he got an error message that basically said, okay, this filter is not suitable, or the type or the data type or data space type of this data set was not suitable for this type of filter, meaning Fletcher 32. And it turns out that if you had used an older version of H5Pi or the HDF5 library for that matter, you probably would not have seen this message. Unfortunately, it doesn't mean that it was done previously and either H5Pi or the HDF group introduced a bug here. This is really, there was an additional check added, and it was first released with HDF5 1.12.1, where when a user tries to apply checksumming or Fletcher 32 filtering to a certain chunked data set, the library actually checks if that is actually an appropriate thing to do for that data type. And I'm going to explain what I mean by what is a type for which checksumming is appropriate and what is a type for which such checksumming is not exactly inappropriate, but it may not do what the user thinks this does. And variable length strings, or for that matter, any kind of variable length data would be an example of such a type that is deemed inappropriate for applying checksums. And the reason is the following, that currently when you have a chunk data set and the data type of the elements on that chunk is a variable length sequence data type, or it contains variable length information. It's not a fixed size type. It's not a fixed size type like integers or a compound that has only integers and floats. So something the size of which you know at compile time. And variable length sequences are one example of that. Another example could be, for example, region references or something like that. Then what's stored in the file, the layout of the data set elements is actually different for these fixed size, for these elements of fixed size data types from the elements of variable size data types. Because in the case of the fixed size data type elements, they are indeed stored on the chunk, as many as the chunk size specifies. However, in the case of a variable size data type of these elements, there is typically an auxiliary structure that describes that variable length data type, and these descriptors are actually one for each element, are stored on that chunk, whereas the payload, the data themselves, are actually stored on a structure that can accommodate sort of elements or representations of elements that are to a degree of an indefinite size, so-called heaps. And so case in point, variable length data, the way the HDF5 library stores variable length sequences, for example, is that in the API, there is a structure called HBL_T, and that is basically a structure that has two elements. One is basically a length field of size t, where you basically indicate how long that variable length sequence, how many elements it has. And then there is just a pointer in memory that points to the first element of that sequence. Now, and then there is obviously a counterpart of that to represent this variable length sequence in the file. However, logically, you can think of this as, if you have a variable length string data set, or I'll show you an example compressed. So if anything is compressed or filtered, it's really the things, in this case, the descriptors of these variable length sequences that are filtered or compressed. So you could say, well, what's wrong with applying Fletcher 32 checksumming to these descriptors? There's nothing wrong. The only thing that's wrong with it is that it's misleading. It's misleading in the sense that, yes, you could detect a change, let's say, in any of these descriptors. However, that has no bearing whatsoever on the payload, on the actual sequence elements, and was, if a change should occur to that heap, to the elements, to the payload of the sequence, but no change to the descriptors on the chunk itself, there would be no way of knowing that, because the Fletcher 32 checksum of that filter would not change. And so it would be ineffective and misleading. And I think that was one of the main reasons behind making this change, to alert users and say, hey, if you are trying to checksum this for these variable length sequences, you would be, if we did it, you would be fooling yourself, and you would sort of have a sense of assurance that is really unwarranted. And so that's why this occurred. Nevertheless, if you use other filters like compression filters, for example, and I'm providing an example here, you can see that compression indeed takes place, for example, for these variable length sequences. However, it's important to stress what is being compressed are not the elements of these sequences, but these sort of descriptors that you can, again, in memory terms, think about as pairs of pointers and sequence lengths. And so here's the example. We are basically creating an HDF5 file. Here we are creating a variable length sequence type of integers. So the data set elements of a chunk data set that we are constructing here, that data set will have 2048 elements. And we are setting the chunk size to 1024, so we will have per chunk 1024 variable length sequences. We only know that there will be 1024 sequences, but for each individual sequence, we do not know how long it will be. Some of them might be empty, some of them might be very long, some of them might be short. We just don't know. And I'm saying here that I would like to apply gzip compression level 1 to this. And then we just go ahead, create that data set. And I'm creating sort of a fake data set here. So a data set, in-memory data set of 2048 elements. And the way I'm constructing this, I'm basically constructing sort of a periodic set of sequences. So you can think of that buffer that I'm creating here as a ragged array, where the first element is just the sequence that contains the element 0. The second element is the sequence that contains 1 and 2. The third element is 3, 4, 5. The fourth element is 6, 7, 8, 9. And then the same thing all over again. So 0, 1, 2. So that's what the dot, dot, dot stands for. And I'm just sort of initializing these H5VL, that's that type here. I have to initialize the length of the sequence and then the pointer. And then I'm just writing this data set and everything works. It's just fine. And so when I run h5dump on this file that I created this way, you can see that's my chunk size. And you can see there is a good deal of compression going on, 5, almost 6 to 1. That's good. Compression is gzip level 1. But the important thing is, what is being compressed here are not these sequences here, these 1, 2, 3, 0, 1, 2, 3, 4, I forgot already where they went. What's being compressed are not these sequences here. What is being compressed are really these descriptors of these two fields of pointer and type. And that's important to remember. And however, what you can confirm is that at least with this version, I ran this with HDF, with the current developed branch, which is 1.13. The filtering fails if instead of doing gzip compression up here in this dataset creation property list, I enable Fletcher 32 instead of deflate. And then that test kicks in where the library says, well, wait a minute, this is a variable length sequence type and you're trying to do checksumming on this. You are fooling yourself if you are doing this. So that's how things stand currently. And this is what this post was about, more or less. And I think that's it. We are at the end of today's session, and thanks for coming, and come back next week, ask questions, and I'm sure there will be plenty of discussion on the forum. Thanks for coming, and enjoy the rest of your day. Bye.